All right, so now we're asking whether, so we have a much more complicated grammar now, and we're asking whether the AND operator is left or right associative. Give an example sentence and parse tree. So associativity is about if you have multiple operators at the same level of the expression, which one is evaluated first. So we want some sort of sentence where we have two AND operators, and we have to decide which of them to do first. So this is our basic assignment grammar, so we'll start with a sentence that is just sort of very similar to the one that we used before, except that now we're just going to have an AND here. So this is a good example sentence for demonstrating this, because if this is left associative, then we'll do this AND first, and if it's right associative, then we'll do this AND first. And so probably, I guess, the best way here is to just start doing either the derivation of the parse tree, and because the problem asks for the parse tree, then we'll just start with the parse tree. So we'll start with A, which is the root of the parse tree. We expand that to V equals E. Sorry. And then the V obviously becomes an X. And so now we need to kind of push this down, and you'll notice that this grammar is a little different than the grammar that we saw before, because now we have multiple levels of the grammar. So we have an E production, an F production, and a G production. And it turns out that these represent different levels of precedence. And so the production that we want to use here in expanding this E is going to be the one that gives us an AND. And so that means that we have to use this production, which means that the E expands to an E, an AND, and an F. Which means that in order to get another AND, so you should take a little time to convince yourself, but there's no way of getting back to an AND from the F. And so at this point, we have to use this E here to expand using this production again, and that's where we get our other AND from. And so, you know, we could push this through, and in fact, this would be rather lengthy because we'd have to expand the E to an F, and then now we have Fs here. Now we can push through the G, and we don't care about these other operators. So really, it's just going to be G, and then, and obviously, you would want to do this in a way that you don't run out of room, like I did. So G, and then V, and then B here, and then G, and then V, and then C here. But anyway, the important part is not these long chains at the end. The important part is what's happening here. And remember, these trees are evaluated from the bottom up, which means that this ampersand is the one that happens first, and this ampersand is this ampersand here. So if you read the terminals across the leaves, you'll get the order that they are in the sentence. And so this is the leftmost ampersand, and it's the one that's evaluated first, and that's the one on the left, which means that this operator is left associative. And that really comes from this production right here, where the recursive case on E is on the left side. So if we had instead something that looked like this, this would end up being right associative, because what we would end up is a tree that looked like this. So that we'd have an ampersand, we'd have an F, and then we'd have an F ampersand E here, and then, of course, an F. And so it's kind of like this tree, but mirrored. And so here, the rightmost ampersand would be executed first. And so that's how we know that the ampersand associated, or the ampersand operator is in fact left associative.